The topic of this video is from Unit 3B on complements and unions of events. For any event E, the probability of the event E plus the probability of its complement has to equal to a total of 1. All right, for example, let's suppose that there is a 20% chance of rain. Well, what would be the chances that it's not going to rain? Of course, that would be an 80% chance of no rain. Well, as decimals, 20% is equal to 0.20, 80% is equal to 0.80, but if we add together the 0.20 plus the 0.80, that's our total of 1. So the event E is that it's going to rain. The complement of that is that it won't rain. So those two probabilities added together have to equal 1. Let's look at the example. If the probability that a vaccine you took will protect you from getting the flu is 0.965, what is the probability that you will get the flu? So the event E here is, of course, that you are protected from getting the flu. So we're trying to find the probability of E complement. So the E complement here is the event that you will get the flu. So rearranging the formula from the top of the slide, we're going to subtract the probability of E from both sides. That leaves the probability of E complement on the left equal to 1 minus the probability of event E. Well, what's the probability of event E? In this case, it's the probability that you're protected from getting the flu. That's the 0.965. So if we subtract those two numbers, we get 0.035. That represents the probability that you will get the flu. Now let's talk about union of events. If A and B are events, then the probability of A or B occurring is going to be equal to the probability of event A plus the probability of event B minus the probability of the intersection of A and B. Now the key word for the union of two events is the word OR. So whenever you see the word OR with your between two events, start thinking about the union of two events. The word AND over here on the right, that of course indicates intersection or overlap. Now if A and B have no outcomes in common, then the probability of A or B is simply equal to the probability of A plus the probability of B. All right, we say in this case that the two sets A and B, or the two events A and B, are disjoint. Okay, or mutually exclusive events. So there is no overlap between those two events, so the probability of that occurring would be equal to 0. Now we are going to look at an example of each one of these types. The first example, a single card is drawn from a standard deck of 52. All right, what is the probability that it is either a red card or a king? So probability of a red card plus the probability of a king, but then we're going to need to subtract off the probability of a red and king. So the original question is asking for the probability of a red card or a king. So that simplifies to the probability of red. So what is the probability of choosing a red card? and that's 26 over 52. What's the probability of choosing a king? Well, that's 4 over 52, but how many cards in the deck are red kings? The overlap between red cards and kings, there are 2 of those. So adding and subtracting to simplify, we have a total of 28 divided by 52, but that fraction does reduce with a common factor of 4 to 7 divided by 13. Now remember, the key word to look for in this case is the OR in the original question. What about if we still draw a single card from a standard deck of 52 and we're trying to find the probability that it's either a jack or a king? So we're looking for the probability of a jack or a king. Keyword is that we have the OR in there. So we're going to separate this into the probability of a jack plus the probability of a king. But unlike the previous problem, we don't have to subtract anything from this because there is no overlap between jack and kings. So what's the probability of choosing a jack? That's 4 over 52. The probability of choosing a king is 4 over 52. So this reduces to 8 over 52, and in lowest terms, this reduces to 2 divided by 13. Once again, the key word to look for here is the OR, but there is no overlap between these 2 events. So it's simply the probability of the first event plus the probability of the second event. Now let's look at probability questions when we're given a table. Now this table summarizes the results from the sinking of the Titanic. Assume you choose one passenger at random. We want to find the following probabilities. Now look for this question. It has a key word here. We've got an OR in there. We want to know that what the probability is of choosing a girl or someone who died. So we're going to break this up into the probability of choosing a girl plus the probability of choosing someone who died. But there is some overlap here. There are girls who died. So we're going to subtract the probability that they were a girl and they died. So what's the probability of choosing a girl? There are 45 girls out of the total of 2,223. How many people died? Well, in terms of probability, that's 1517 divided by 2223. Well, how many people have I counted twice? Well, if you look at the overlap between the column for girls and the row for those who died, we counted 18 people twice. So we do have to subtract that overlap. So adding and subtracting these fractions, I get 1,544 divided by 2223. Now this fraction does not reduce, so we will leave it in that form. Remember, if you're asked for the decimal of that, just perform the division and round it off as the directions state. Now for the probability of choosing a survivor or a man. So we're going to look at the probability of a survivor plus the probability of choosing a man, and then subtract the probability that the passenger survived and was a man. So what's the probability that the person survived? Well, looking at the row for survivors, there are 706 out of the 2,223 that survived. The probability that we chose a man, that's 1,692 divided by the total. And then how many people have we counted twice? we'll look at the overlap between the survivor row and the man row, and that's 332 divided by 2223. Now remember, it's the overlap between the survivor row and the man column. Right, I apologize, I said that incorrectly. So looking at the overlap between the row of survivors and the column of men. Right, that's the 332. Now if we add and subtract these, we get a total of 2,066 divided by 2,223. And this fraction does not reduce. But the key word to look for here is that we have an OR, so that means we have to subtract the overlap if there is any. Now let's look at an example where we're actually working from the formula for the probability of the union of two events. So let me go ahead and write that formula down to remind us what it looks like. So the probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. So we're going to fill in what we know and solve for the unknown. So on the left-hand side of the equal sign, the probability of A or B, that's given as 0.85. The probability of A is given as 0.33. The probability of event B is given as 0.74. But then the unknown is the probability of the intersection, or the overlap of A and B. So we are going to have to do a little bit of algebra here in order to get the unknown by itself. So let's go ahead and add the two numbers together on the right-hand side, and that gives me 1.07. And then I'm going to subtract 1.07 from both sides of the equation in order to isolate the unknown. So this adds to 0. And then on the left-hand side, that gives me negative 0.22 is equal to negative probability of A and B. And then, of course, I'm just going to divide both sides by -1, and that will leave me the positive probability of A and B is equal to positive 0.22.